Okay, so we're going to continue on with the law of sines and cosines and talk about the ambiguous case and what that means. So, just to kind of review the law of sines and cosines. So, again, we can use the law of sines when we have two angles and a side. So, either the side is included or not included. So, to remind you on what that looks like, if I have angle, side, angle, I have something like this, information about two angles and then a side. And if I have side, angle, angle, or angle, angle, side, I'll have information about two angles and then a side that's not included. So you can kind of see the differences here. We also have the case that we can't prove triangle congruencies, but we can use law of sines here, and that's when we have side-side angle. So if I have two sides and a non-included angle, all three of these we're going to be using the law of sines. And again, here's our law of sines. We can also have it with A over sine of A is equal to B over sine of B is equal to C over sine of C. And again, to kind of remind you, we're looking at capital letters being angles, lowercase letters being the sides. And so when we have our triangle, I'm just going to kind of write down three angles. So ABC, across from angle A is little a, across from angle B is little b, and across from C is little c. And I'll put that little tail there so you can see that it's a lowercase c and not an uppercase c. So one thing to keep in mind here is when we have side-side angle. So if I have two sides and a non-included angle, then I'm going to be using the law of sines. And this is called our ambiguous case. We can have one triangle, two triangles, or no triangles when we have this case. And so it's up to us to decide which one it's going to be. And so to determine how many triangles result, we need to figure out the length of side A. And notice how I've set up my triangle so that angle A is here, so that the other opposite side is A. We need to compare it to our height of the triangle, which we're going to have to find. And if you look at this pink triangle right here, you can see that the sine of A would be equal to h over b, or h would be equal to b times the sine of A. And so we're going to need to use this to help us, and we'll see that in a little bit. So one thing to note, that if this piece here, and we can imagine it might swing, so if I have a piece that's too short, so something like this, I'm not going to be able to make a triangle. So that would be no triangle possible because it's not going to connect all the way. It's possible that we're able to connect it so that it makes a right angle. We would have one right triangle possible. Or if this length of A is longer than h, I could actually swing it. And so what I mean by that is I'm able to take this piece and it's able to make this kind of looking triangle where I have, this is fixed, and this angle is fixed. Or I can swing it so that it goes the other way, and so the actual would actually look something like that. So this is fixed, and this is fixed. Now, this side, this third side, is going to be a totally different side length, and these angles are going to be totally different. And the reason why we can do that, let me see if I can draw what I'm thinking, is this piece can come all the way to here, or it can swing and it can go there. And so these pieces become congruent. And so we're going to use that to kind of help us. So the first thing to kind of think about is if no triangle is possible. So what that means is that we need to figure out, we talked about before, that h is equal to b times the sine of A. And so if my third side, if A is less than h, then there's no triangle. Because if I can't even be as long as the height, I can't even make a triangle. And so one thing to kind of think about in our work is if I have this right triangle, and again, I'm setting it up so that it's A, B, and C. So this is little b. This is h. If the sine of b over b, right, this is another way we can find it. sine of A over H, because across from A is H. So we know that the sine of B is 1, because the sine of 90 is 1. So I'll kind of write that down. Sine of 90 over B equals the sine of A over H. So this is 1 over B equals sine of A over H. I cross multiply, and I get the same thing. So one thing to kind of note here, too, is that if the leg, and I'm going to write this out, opposite the angle is shorter than the height, no triangle is possible. So one thing to keep in mind here, that if the leg opposite the angle, because again, remember, we only have one angle here. So if the leg opposite the angle is shorter than the height, no triangle is possible. And we're always going to want to set it up so that the angle is right here. It just makes it easier for us. So if I calculate my height, and I find out that A is equal to H, so the side that's opposite the angle is equal to the height, then I'm going to have just one triangle. So if the leg opposite the angle is equal to the height, then one right, that's important, triangle is possible. So pretty straightforward. If we calculate the height and we find out that the side that we're looking at is equal to it, we have one right triangle. Because the shortest path between a point and a line is the perpendicular distance. So this is going to be the shortest distance between where this side ends, because remember, this B is going to be fixed and this angle is going to be fixed. That the only possible ways to get from here to here in the perpendicular fashion, there's no other way for me to do it. Because if I were to move this, it would then be short in both directions. But if this side isn't even long enough, it's not equal to the height, then there's absolutely no way that we're going to be able to make a triangle whatsoever. So if we look at this, if we have one triangle, now we don't have a right triangle here, but if I look at the fact that side A, which is across from the angle we have, is greater than that other side, there's only one possibility. So if we think about our height here, this is going to be our height. A would obviously be greater than the height, but the most important part is that A is going to be greater than B. So if the leg opposite the angle is longer than or equal to the other leg that you have information about, one triangle is possible. And notice here, it is not a right triangle. It's just one triangle. So it will most likely be an obtuse triangle there. Now, the more complicated one is when we can have two different triangles. So if I calculate the height and I notice, so if I draw my height right in here, and I notice that H is smaller than A, and A is smaller than B. So this other information, this other leg that you have information about, if this is bigger than that other side across from the angle, and if A is greater than H, right? Remember, because if we know that A is smaller than H, then we don't have a triangle at all. If A is equal to H, then we have a right triangle. So if A falls in between those two distances, then we have two possible triangles. So you'll kind of see here that A can swing, and it can make the two different triangles. I can make this pink one out here would be one triangle. And then I can also make, I'll make this green. I can also make this triangle in here that I'm writing in green. That would be your other triangle. And so notice that both of them have A, both of them have side B, and they all have side A. But notice what's different. This angle here is different, this angle here is different, and this side is different. So 3 pieces remain the same, and 3 pieces are going to change. So if A is between H and B, then we have 2 triangles. So if the leg opposite the angle is shorter than the other leg, but longer than the height, 2 triangles are possible. So shorter, longer, 2 triangles. So it has to be between the height and that other side. So we've talked about the theory. We've kind of explained all those. So let's look at some examples. So solve the triangle. A is 2, C is 1, and C is 50. When you set this up, you always want to set up the angle so that it's at the bottom left-hand corner, and then the 2 sides are going to be at the top. It just makes it easier so you always have a pattern to follow. So when I set up my triangle, I'm just going to go ahead and draw in a triangle, and I'm going to put this as 50 degrees. So this is C. I know that C is 1, so I can put a little c here to kind of help me. And then my other side would be A equals 2. So this would be capital A, and this would be capital B. All right, so what we want to do is first figure out what's our height. So remember, H would be equal to, and if you don't remember how to find that, just do the sign. So sine of 50 is equal to H over 2. So 2 sine of 50 is equal to H. You can remember the formula, which the formula we found was right up here. It's the current side that's closest times the sine of this angle. But sometimes our letters change, so we just want to make sure that we're able to do that. So we want to figure out what that is. And so if I plug that into my calculator, I find out I get 1.53209. Okay, so what we want to figure out is my height is 1.5. So it's like 1.5. So if my height is 1.5, whatever, for example, and the opposite side is 1, since C is less than H, 1 is less than 1.5, there's no triangle. No triangle is possible. Because that opposite side is shorter than the height. So we can't even make a right triangle. So it's shorter. So in reality, this triangle would probably look something like this. This would be 50 degrees, this is 2, and this is 1. So it's going to be short, so again, we have no triangle possible. All right, so let's set up the next one. Why don't you take a second, pause the video, and set it up. Okay, so when we do this, we make our triangle, and I just draw any kind of triangle. I always draw this shape, I don't know why. But here's my angle, which is 40 degrees. So across from it is A, and that's 3. And then B is going to be 2. B and C. So we want to double check our height. So I always like to find the height first. Just because I like to just make sure that I know what I'm looking for. So the sine of 40 degrees is equal to H over 2. So 2 sine of 40 equals H. And so when I do that, I find out that H is 1.286. Perfect. I see that this opposite side is greater than the height. Beautiful. Now, I really didn't have to do that this time because I see right away that A is greater than B because 3 is greater than 2. So that should tell me right away I have one triangle possible. So I only have one, so I'm just going to solve for the 1. Now, if this was a different value, like it was 1.5, then we would have had a different scenario. But since this side that's opposite our angle is larger than this side, I know right away I have one triangle. So let's figure it out. Let's solve it. So what I want to do is I'm going to erase these, my height for right now, just so I don't get turned around. I'm first going to start with the law of sines because I have information about the A's and part of the B's. So when I do that, I'll do the sine of 40 over 3 equals the sine of B over 2. So this kind of digs into the last little bit that we did when we were solving triangles previously. So I'm going to multiply by 2, and I'm going to keep the 3 in my denominator. And that equals the sine of B. Now I need to take the inverse sine. It always goes in front. The inverse sine of both sides. And so what I want to see is that we have the inverse sine of 2 sine of 40 over 3 equals B. And so when I do that, I find out that B is equal to 25.374 degrees. So I've now found this angle, and so we can write that in there if we want. This is 25.374 degrees. And you could save that in your calculator. We talked about how to do that before, where we store it in our calculator as B, because we might need it again. And so to find C, I could do the law of sines again, but it would be kind of tricky because I don't have that angle. So the best way to figure that out is to do that C is equal to 180 minus A plus B. So C would be equal to 180 minus 40 plus 25.374, because we know that all of the angles in the triangle add up to 180. And so what I'm left with for C is 114.626 degrees. And so we can write that in if that helps us. And then now we just need to figure out what AB is going to be equal to. And so to do that, we can just do the law of sines again. And this time we'll use that angle that we just found. So it doesn't matter what you do. I'm going to use A because those numbers seem to be a little bit nicer. So I'll do it the other way this time. So 3 over the sine of 40 is equal to AB, because that's what we're looking for, over the sine of 114.626 degrees. So I would multiply by both sides, and I get 3 sine of 114.626 over the sine of 40 would then equal AB. And so when I plug that into my calculator, I find out that AB is going to be equal to 4.243, and we don't have any units, so that would be your final answer. So then we found all of the pieces of our triangle, and you can write on here if you want. So that would be 2, 4, 3 for that. Okay, and then the very last one is this case. We're going to draw it out again. So I have my triangle. I'm just going to draw it over here. So A is 35 degrees. So this would be 6. This would be 8. And so this would be B and C. So I see right away that I need to figure out what my height is. So height, so if I think about the sine of 35 degrees would be equal to height over 8, because again, your height is going in right there. And so I want to figure out if that's h, sine of 35 is h over 8. So 8 times the sine of 35 degrees is h. And so when I do that, I should figure out that my height, when I plug it into my calculator, is 4.58861. And so when I compare that to these values, I see that h is the smallest, followed by A, followed by B. So I have 4.6, for example, then 6, and then 8. So that tells me I have two triangles possible. So I need to figure out both of the triangles. And so the best way to do that is to solve for this shaped triangle first, and then we'll look to solve for the other one. So when I draw this triangle, we know that this is 35 degrees, this is 6, this is 8, it's A, B, and C. So I'm going to do the law of sines. So I have the sine of 35 degrees over 6 is equal to the sine of B over 8. So 8 sine of 35 over 6 equals the sine of B. And then I have the inverse sine of both. So I know it's kind of hard to see, but we're looking at the inverse sine of both of them. So the inverse sine of 8 sine of 35 over 6 equals B. So we find out that B is going to be equal to 49.886 degrees. So again, if it helps you, write that in, 49.886 degrees. So to find angle C, I take 180, subtract 35 plus 49.886, and so I find out that angle C is going to be equal to 95.114 degrees. And then to finish things off, I can do the sine of 95.114 degrees over AB is equal to, actually I'm going to do it the other way because I'm looking for AB. So AB over the sine of 95.114 is equal to 6 over the sine of 35. And so I'm just going to solve this. And so I find out that AB must be equal to 10.419. And so now I've solved everything in that first triangle. And I know I didn't write this in here, but you can if you want. And so now I have all the pieces of information that I needed for that triangle. Now, on the other hand, we also have to look at our other triangle. And so to figure out what that other triangle is going to look like, we take our triangle like this. We know it's going to be swinging the other way, that these are both the same. So this is going to be 8 and 35. This is A. I'm going to call this one B prime, and I'm going to call this one C prime because I just want to label them something different. And so I know that this is still 6, this is still 6. So we found originally that this angle here was 49.886 degrees. So this triangle from C prime to B prime, and then this was B, is an isosceles triangle. So this angle must also be 49.886 degrees. So if I'm looking to figure out what this angle would be, I know that both of these here have to add up to 180. So B prime would equal 180 minus B. So B prime would be 180 minus 49.886. And so B prime must be 130.114 degrees. And so when I'm looking at my new triangle, which is now something like this, I have A, C prime, and B prime. This is 8, 6, and 35. I know that this is now 130.114. So now I can find C pretty straightforward. C prime would be equal to 180 minus A plus B prime. 180 minus 35 plus 130.114. So C prime must be 14.886 degrees. And so this guy in here would be 14.886. And then now to figure out what AB prime would be, I can just do the law of sines again. So AB prime over the sine of 14.886 has to be equal to 6 over the sine of 35 degrees. AB prime is equal to 6 sine of that. And so when I plug that into my calculator, I'll get 2.687. I haven't been boxing my answers. So this would be 2.687. And so you can see if you compare these two triangles here, that this angle is much larger than this one. This angle is much smaller than this one. And this side is much bigger than this one. And so you can imagine that we are swinging that third side, and then that's what makes it into its other triangle. And so that's when two triangles are possible. Okay, the last thing I want to talk about really quickly is the law of cosines. We have talked about this in the past. We know we can use it when we have side angle side or side side side, and these are our three different options for using the law of cosines. And so for our last example, I just wanted to show what that would look like if all we were given were sides. And so we would have to use the law of cosines here because we have all sides. So it doesn't matter where you put them. I'm just going to put the three sides down. So I have 4, across from B is 3, and then across from C is 6. And so it doesn't matter which one you use. Let's just solve for angle A because it's right here. So I would have A squared equals B squared plus C squared minus 2BC cosine of A. And you can look back in your notes for that. So I know what A squared is. It would be 4 squared equals B squared, so 3 squared plus 6 squared minus 2 times 3 times 6 times the cosine of A. Okay, so this is where things get tricky. We cannot combine all of this together because there's a multiplication symbol here. So we need to combine these together, combine these, and then we'll slowly start to make it work. So I get 16 equals 9 plus 36 minus, now I'm going to multiply this, so that would be 6. That would be 36 cosine of A. These I can then add together to make it 45 minus 36 cosine of A. Be careful that you do not subtract here because that's not true. That's not what we're doing. We're going to subtract 45 to the other side because remember there's multiplication happening here. So I would get negative 29 equals negative 36 cosine of A. Now I can divide by negative 36. And so what I end up getting, these become positive. 29 over 36 is equal to cosine of A. I'm going to give myself a little more room here. Now I want A, so I take the inverse cosine of both sides. And so what I'm left with is the inverse cosine of 29 over 36 equals A. And then when I plug that into my calculator, I get 36.336 degrees. And so that's what this angle is going to equal. And then from here, you can do the law of sines, and then you can figure out what C is. And so why don't you go ahead and take a second and do that, and then I'll put the answers in here for you. And so you can see here on the right that I've done the law of sines with angle A and B in order to figure out what B is equal to. And then I was able to just subtract the sum of those two angles I knew from 180 to get angle C. And so that's it.